Hello. So in this video, we are going to extend the binary distribution model to the binomial distribution model. So the difference between the binary and the binomial distributions is that the binary random variable x is just a single binary random experiment, right? It's either 1 or 0. Like one question, you are randomizing in one question, but the binomial random variable, which I'm going to denote as y, is the number of successes in a number of binary experiments. So it's not a single binary case. So multiple binary experiments are repeated. For example, flipping multiple, tossing multiple coins, or in your homework, you are doing 10 questions, not just a single question. So, so we count, so when you throw, say, 100 coins, you can count how many of the coins have heads. Then that is binomial distribution. So single coin is a binary, but you are doing that 100 times. Or single question is binary, correct or wrong, but your total grade, your point from the homework is like from 10 questions. So single question is binary, but your homework is a set of 10 questions. So it is a binomial distribution. So y is, as I said, it's the number of successes. So y can take integers between 0 and n. So when you throw 100 coins, the number of heads can be at the minimum of 0. No coin has heads, or at the maximum of 100. All coins have heads. Similarly, in your homework, the minimum grade is 0 and maximum is 10, right? So the binomial distribution ranges between 0 to n. So then we will discuss what's the required assumptions and then how we can understand the binomial distribution in an hour. It will be more complicated. So the assumptions we are going to make is like this. N trials. So you repeat binary experiment n times. N is the sample size, the same sample size n. And like in each trial, in each experiment, it's binary. So there are only two possible outcomes. And of course, we are going to use 1 and 0. And in each trial, the probability of success is the same, P. P is the same probability of success for all trials, right? And finally, the fourth assumption is actually important. The trials are statistically independent. We learned independence in the previous chapter. That means when you throw 100 coins, the first coin and the second coin, the result of the first coin does not affect the second one. And when you do the homework, your result from the first question does not affect the following questions. So that's independence. Concept, like simply speaking. So we are going to study independence, again, review the independence in a moment. But anyhow, under these assumptions, if a random variable is generated from this experiment satisfying these assumptions, then y is the number of successes from those experiments, then that is binomial distribution. The binomial random variable follows binomial with two parameters. Now, there is an additional parameter, n. N is how many times you repeat a binary experiment, and p is the probability of success in a single binary experiment. So in the binary case, n was 1. So there it was not a parameter. But now you may increase the number of repetitions, so it becomes another parameter of the distribution model. Right? So we use this notation. So let's go back to the homework example. Suppose that in the homework you have 10 questions and you have no idea at all how to solve any of them. So you randomize all the questions, randomly choose like A, and submit, and see, randomly choose all the answers and see how many points you can get. And the definition is the same. For question I, xi, I'm going to denote x subscript I is the point you get from question I. So you get 1 point if you choose a correct answer. You get 0 if you choose a wrong answer. And we know that from each question, I assume that, so each question has 5 choices, so the probability of choosing a correct answer at random is 20%, 1 out of 5. And then your grade from that homework is the sum of each question's result, And by the way, remember the number of correct answers equals to the sum of the single outcomes. So we learned that earlier. So when you have only zeros and ones, sum them is equivalent to counting the number of ones. So that's why I wrote it this way. And then the possible outcomes are 0 to 10. You can get one of those grades. And then y is a binomial distribution with 10 and 20%. 2 parameters. These 2 parameters are enough to calculate the full distribution of this random variable. By the way, this is a stronger simplification because now the number of possible outcomes are 11. There are 11 possible outcomes, including 0 to 10. But so 11, there are 11 outcomes, so you need to know 11 probabilities to fully understand the randomness. But actually, what you need is only 2 numbers instead of 11 numbers. So you know how much it can simplify, right? Okay. So, and I'm going to give you another example, which is the running example throughout this chapter maybe, and like throughout this course semester. I will use reservation as an example. Suppose that you are a manager of a airline. So you get 10 reservations for a flight. So, or you can think about a restaurant, hotel, whatever. There are 10 reservations made, and you are the manager. You are managing the reservations and cancellations. But the problem is, the difficulty in managing the reservations is in the probability of cancellation. So it may be canceled, or a reservation may be canceled with 10% probability. So single reservation can be canceled with 10%, and there are 10 reservations, so each reservation is independent of the others. That means the cancellation of the first reservation has nothing to do with the second reservation. Those those people who reserved the flight do not know each other. They don't know. So they are independent. And I am going to define random variable x subscript I from a single reservation I. And I'm going to write 1 if the reservation is cancelled. Remember, by the way, I'm going to put cancellation as success. As I said, it's not good, but we are counting cancellations, right? We are counting cancellations, so we call them 1 or success. So remember, so definition can be, the notation can be confusing. So 0 if not cancelled. And then y is the total number of cancellations. Then it follows a binomial distribution with np, and the parameter n and p, but n is 10 because there are 10 reservations, And because each reservation has a probability of 10% for cancellation, so the P is 0.1, 10%. So this is another example we use for the binomial distribution. Then let me ask you this question. So the same example, you are the manager of a flight and you got 10 reservations, or like say restaurant. You are a restaurant manager and in your restaurant tonight there are 10 reservations. But each reservation can be canceled with 10% probability and all the reservations are independent. Then what is the probability that exactly 2 reservations are canceled and 8 tables are served? What is that probability? So by the way, it is natural. You don't know what is the answer. I did not teach you how to calculate this probability. We are going to calculate this probability from now on. Just I'll have you guess what would be the answer. So the numbers you can combine is like you can use is like 10 reservations, 10%, 2 reservations. There are 3 numbers. So you may try to combine those 3 numbers to get some like answer here, but the correct answer is 19.37%. Actually, this is rounded number. It's more complicated. So what I'm telling you here is the binomial distribution is not that simple. It is more tricky and more complicated and requires actually a more complicated steps to get to the answer. But like without learning statistics, you cannot understand what's going on. It's not just 20%, not 10%. And of course, if you change the numbers, the numbers could be more like strange, weird numbers may come up. So our goal is to understand why we get this strange number as the answer. And to do that, we have to go through some like 6 steps just for for introductional purpose. It requires step-by-step procedure to explain the idea. It's pretty tricky and could be counterintuitive. So please follow me, and I'm going to start in the next video. First, I'll start with reviewing the statistical independence first. See you later.